Okay, we will be starting now. Hello, everyone. Dear authors and invited guests, welcome to Technical Session 5B. My name is Dimahi Patel and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Machine and Computing Technologies for Sustainable Development, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held in Manila, Philippines, and the virtual event is being held through Zoom yesterday and today, that is 12th and 13th December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question and answers. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to us in the chat box. Now, before we start the session, I would like to introduce you all to the chair session. We have with us Dr. Juliet Menor. Dr. Juliet serves as the department chairperson of the Business and Office Administration Department at Pangasinan State University, Philippines. Her expertise encompasses machine learning, classification, neural networks, artificial intelligence, advanced machine learning, data mining, and knowledge discovery. Applied AI and machine learning along as well. With a strong foundation in emerging technologies, Dr. Menor is dedicated to fostering academic excellence and promoting innovative research in intelligent systems and data driven solutions. A warm welcome to you, ma'am, and I request you to share any few words you may have for the presenters today.
Thank you very much, ma'am. Okay. Good morning, everyone. It is my pleasure to welcome you all on this research presentation session. Today, we gather the presentations to share the knowledge, exchange ideas, and highlights the important work of our researchers. As a session chair, I am honored to guide this session to ensure the smooth and meaningful of the discussions. This research or the research is more than requirement. It is the commitment to ensuring innovation, continuous improvement. The studies you will hear today reflect the dedication, curiosity, and hard work to our presenters. And I encourage everyone to engage actively, ask questions, share insights, and contribute to collaborations of a learning environment. Let us this opportunity learn and listen. Let's begin, ma'am. Thank you,
Yes,
ma'am.
thank you so much, ma'am. We also have with us Dr. Nilesh Popat Sable as our session chair. Dr. Nilesh has overall 15 years of academic experience, presently working as SPPU approved professor in the Department of Information Technology, Vishwakarma Institute of Information Technology, Pune, India. He has published 50 plus papers in national, international conferences, and journals. He has filed and published 14 patents and 3 copyrights. He is the author of a couple of books with an international publisher like Lambert. Welcome, sir, and please share a few words you may have for us today.
Yes, thank you, ma'am, for the introduction. I would like to take this opportunity to thank GR Foundation for the opportunity to serve as an session chair for this technical session. We are having presenters here. I wish we would be looking forward to hear the contributions which they have made as a research paper and to see that how exactly they have overcome the difficulties and the problem statement which they have identified. So thank you. Looking forward to it. Thank you, Vanana.
Yes,
And all
thank
the
you,
best
sir.
to all the participants.
Yes,
Yes.
okay, we will be starting with the presentations now. I would like to call Sagar Mikala. Sagar, sir, are you present? I repeat, Sagar, sir, or any of the co authors of this paper. Vidhi Sutaria. Vidhi, ma'am?
Yes, ma'am. I'm here.
Yes, ma'am. Please present your paper on comprehensive ECG waveform analysis for machine learning based classification.
Sure. I'll just share the screen just a second.
Sure, ma'am.
Is the screen visible, ma'am?
Yes, ma'am.
Okay, fine. A very good morning to all the people present over here. Myself, Vidhi Sutaria, and my co-author is Dr. Arpit Jain, and my paper ID is 129. I am presenting over here comprehensive waveform analysis for machine learning based classification. So it is presented in the conference which is held in Manila, Philippines. I would like to elaborate over here. Just a second, ma'am. I'll just share the screen properly. So I'm working on the ECG analysis. In today's world, the lifestyle of the people is very fast paced. So I am working on ECG signals, which is being classified using a data set called PTB Excel. This data set is online available, and I am using this data set for my analysis. Just a second. Yes. So the flow of my paper is I'll introduce my work. I have studied various data sets. I just describe a data set in a very short brief about the data set which I have used and what methodology, what processing I have done on my ECG signals and what results I have occupied. So in this presentation, I would like to elaborate that I'm using an ECG signal. This ECG signal is the heart's electrical activity. You can see in the picture, the ECG signal is processed like this. There are various waves. The waves you can see over here is P, Q, R, S, and T. These are the waves which are continuously moving in the ECG signal. The whole signal can be processed in various n number of times. My data set which I am using has these waves. So every ECG signal, irrespective of the data set, has these waves. These waves repeatedly are going on depending on the time duration which is being measured in the ECG signal. So for example, if the ECG signal is of 1 minute, the whole ECG signal will have multiple P waves, multiple QRS waves, and multiple T waves. Now this P wave is the upper heart chamber. When the heart contracts, the P wave is active. Then what happens when the contraction of the lower chamber comes? The waves called QRS actives, and when the heart is relaxed, then this process is completed, the T wave exists. So actually the whole waves are repeated multiple times when we breathe in and breathe out. So the waves are bifurcated in the whole ECG signal. The whole ECG signal is bifurcated in every. So there will be multiple P waves, multiple Q waves, multiple R, multiple S, and multiple T. Depending on the length of the whole signal, the number of waves can be different. So if the signal is of 10 seconds, the waves can be lesser. If the signal is of 1 minute, 2 minutes, 4 minutes, the signals will be greater on. So multiple waves can be detected through the ECG signal. This figure which I have kept is a sample figure. I'll show you the figure of my actual data set also. This is a small representation to understand the ECG signal such that what happens in a shorter wave, because when we see in the whole wave, we'll not be able to identify exactly. So these are various diverse data set which are currently available in online systems. The data set which I have selected is PTB Excel. This data set is of 10 seconds. This data set contains the ECG signals of 18,869 patients, and the total ECG signals which are being captured is 21,799. You can see the patient is lesser and the ECG is greater because there are some patients which are repeated. There are some patients who are coming in the follow-up and again the ECG is done. So that is the reason the exact ratio is of the signals is greater than the patient. But still, patients are 18,000 and 21,000 is there are some patients who have repeated ECG done because of their some other condition, because of some medical history also. So the total signals which I have in my data set is 21,799. Now all from this 21,799 ECG signals, the whole data set is divided into 5 different classes. These 5 classes are, you can see the first is the class name, which is in the ECG. The class name is normal. Yani if the person is not having any such issues, that is a normal ECG. That person is coming because of the follow-up, because of just a body checkup part, and because of some anxiety also, but the signals are normal. That means the person is having a normal ECG. So that category of signals are something 9,000. Then the second category, irregular heartbeat. Some patients are having heartbeat irregular, that is called conduction disturbance, that is CD. The SCP code, the second column which you are seeing, is my category which is being depicted in the data set of the class name. So this is the class name which is actually in the data set, that is CD. Then the third category is heart attack, that is called myocardial infarction, that is MI. The fourth category, if the heart muscle is thickening, that is hypertrophy, which is something which is related to a medical term. And when the blood flow to the heart is reduced, that particular is called STTC, that is ST change. S and T are the waves which are being done. So total number of records which are there in the ECG, you can see on the last column. The data set is divided like this. The total data set is of 21,000 signals, but if you do the total of the total number of records, it would be greater. The reason is there can be multiple classes for a person. For example, a person is having thickening of the heart muscle also and irregular heartbeat. So one single ECG may have multiple classes. So it is like one person is having one or more disease. So the multiple classes can be associated to one single ECG signal. So this is my basic description. The whole data set is divided into various signals. These signals are being processed. So this is the total sample size, the class name which is in the data set, and the total sample. And basic description is here for a normal layman person, because a normal layman person will not be able to understand conductional disturbance. That is a medical term. So it is a very layman language which I have been described for my classes. So for every ECG, again, this is a sample size. For every ECG, the most relevant wave is my R wave. The R wave is the tallest wave in any ECG. So if you see any ECG, every ECG will have a basic prominent R wave. Yes, the amplitude may differ. Some R wave may have a higher amplitude, some R wave may have a lower amplitude. But it is the most prominent wave which is being identified in an ECG. The rest of the waves are useful, but major focus is done on the R wave. So how can we identify how the data set is being divided and how the data set is being processed? I have extracted every feature called heart rate variability feature. Heart rate variability feature is the feature which is being extracted from the R. You can see I have written over here the gap between any two wave. For example, the R wave is called the RR interval. This is the most prominent interval used for an ECG to identify the classes. Now, it is not like that this data set will be having only, this data set is having only 5 type of classes, but if we move to another data set, that data set may other classes. So I am focusing on 5 classes because my data set contains only 5 classes. Now, this is the actual signal of my data set. This signal is actually in the form of DAT file. The data set is in the DAT file. Every data is being divided. Using Python, I have converted every signal into a signal format. The data is in descriptive format. Using the Python processing files, I have converted. So this figure which you have seen, one sample I have kept for every category of my class. There are total 21,000 signals, so possible that I cannot put it over here. So one sample I have kept it over here. These are my total 5 different classes. Every file is being processed. After processing every file, the signal is being generated. You can see the signals over here. There is a dots connected, blue, red. These are my waves. The waves which I showed over here. P, Q, R, S, and T. Every wave is being detected using the Python library and the value of these waves. Now, my data set is of 10 seconds. Maximum 10 seconds data set is being there. This is the sample of one data set. For example, the first is the normal in 10 seconds. So for every ECG, I have calculated these parameters. These are called my heart rate variability parameters. Every parameter is computed like, for example, the P wave. P wave is the wave which is being shown over here. You can see the P wave. There is a peak which is being generated. The peak is being founded by the signals, and I have found the average. See, there are multiple P waves. So average of the P wave amplitude means the height of that. What is the lowest amplitude of the P wave? What is the highest amplitude? For every single wave, all these three features are being calculated in the Python library. Sorry. So average of P wave, average of Q wave, the lowest Q wave, the highest Q wave, so that we can find it out that if a person is having a normal, the machine can identify what are the features of the P wave, what is the highest P wave, what is the lowest P wave. Same way for R, the highest amplitude of R, the lowest amplitude of R, and the average of the R amplitude. R is the most prominent wave of the ECG signal. Every ECG signal will have a highest peak. So the highest peak of the signal which is having, that is called the R peak. Then coming to the S signals, I have calculated the average of the S signals, lowest of S signals, and the highest amplitude of the S signal. Same for T. Now, RR interval. RR interval coming to on the right hand side, fourth line, average of the RR interval is calculated. That is, what is the gap? Because when we have various categories, the gap may increase or decrease. So depending on that, every RR interval is being calculated. The median of every RR interval is calculated, standard deviation, root mean square, PNN. NN is again the same notification of RR signal. You can use RR interval or NN interval alternatively. So a percentage 25%. That means I have calculated the total number of intervals which are having 0.25 milliseconds as the gap. So total, for example, from the whole, there are only 5% who are having 25% gap, 25 millisecond gap. So that is being calculated. Same for 50%. Then finding out the heart rate using the RR interval. RR interval divided by 60 will be the heart rate, the gender of the person, age, and the final class. So for each and every signal, this whole calculation is being done for 21,799 signals. The whole data set contains multiple rows. Multiple rows, the reason is if one particular ECG ID is having two classes, the multiple rows are generated. So the total number of rows are increased more than 21,000, approx it is 25,000. So the data set contains all these columns, and every column is being computed for each and every signal, and the class is being generated. This data set is given to the machine learning to learn and to classify into various classes. So using the data set, I have applied the algorithm, decision tree, naive Bayes, SVM, KNN, and random forest. And the accuracy which I have get is for decision tree, it's 65%, naive Bayes is 60%. So support vector machine is 65%, KNN is 66%, and random forest 78%. From these, I have just analyzed that the random forest algorithm gives 78%. Still, I am working on this. I am planning to add on CNN model in this to identify or to convert the image into various numbers and identify. I want to get the accuracy more than 78, which I am getting right now for random forest. So the next future plan for my work is I'm going to apply CNN model and maybe other machine learning models to check whether it is working. If this does not work, I will be moving to the ensemble learning, that is stacking, or maybe working on multiple models and getting the more accuracy. Thank you. Any questions from your side?
Ma'am, any questions?
It's nice presentation.
Thank you, sir.
You brief in just one line that what is exactly your contribution? Because the data set which you are using, it has already been used by a number of researchers, and
Yes.
the same things has been done. So what is exactly your contribution in this research?
Sir, the data set which people have worked, they have more worked on image processing. There are hardly papers which are working on numeric conversion of numerical data from these signals. So people have worked on image processing more. Many rare people, I'm not still not got the people who have converted the data set or the signal into numerical format, which is more convenient for a machine learning to adapt. So this is my major contribution. Working on the data set from signal to numbers was a task.
See, the accuracy which you have got, it is not justifiable, right?
Yes.
So what measures, as you proposed, you are going to work on something which is ensemble and all that things, right?
Yes.
For
Yes.
you are going to work it for increasing the accuracy.
Yes, increasing the accuracy, and that is the major concern from my side.
Okay, fine. Thank you. Thank you. That's it from my side.
Thank you, sir.
Juliet ma'am, any questions?
Good morning, ma'am. Again, my questions is, could you mention, ma'am, the main objective of this research study?
Ma'am, right now I am working on this predefined data set which is publicly available. The next plan from my side is I'm gathering the data from multiple resources and I want to classify the real-time data. That is my future plan and my contribution more into it, the research.
Okay, so my second question is, what are the challenges or common encounter in the ECG signal analysis?
Yes, ma'am. See, if we get the data from, for example, hospitals, they will not have classified data. That is the most important challenge, because possible that this particular data set is having 5 classes, but the real-time data may not have classes. If we have seen a normal ECG, there it is not every time that you will get the prominent waves every time. So there are challenges to find out that if the wave is not present. For example, if we are doing for a person who is having a very less heartbeat, then that person may not have every wave prominent. To extracting that wave would be the most important challenge in the ECG.
Okay, ma'am. Another question is, what is the impact on your study in the real world?
Well, ma'am, if we actually work more on this, it would be beneficial using the system itself, which is extracting the ECG from a patient to firstly identify that what type of ECG is there. So primary first moderation can be done before the doctor arrives in the hospital.
Okay, ma'am. Thank you very much.
Thank you,
That's it,
ma'am.
ma'am.
Thank you so much, ma'am.
Thank you,
So
ma'am.
next, I would like to call Vasil Svetkov. Vasil sir, to please present your study on hybrid intelligent systems in medicine, automated medical station.
Thank you for the given word. I will now try to load the presentation. Just if you could provide a quick feedback if you can see it.
Yes, sir, we can see your screen.
Thank you. Hello, everyone. My name is Dr. Vasil Tsvetkov from the Bulgarian Academy of Sciences at the Institute of Robotics. Today, together with Associate Professor Vlochkova, I will present our work titled Hybrid Intelligent Systems in Medicine, Automated Medical Station. This research is part of our ongoing effort to integrate service robotics, cognitive AI, and medical automation into next-generation healthcare infrastructure. Excuse me. Yeah, as many of you know, healthcare worldwide is facing several critical pressures. There is a growing shortage of healthcare workers, especially in high-demand environments such as emergency medicine, remote areas, and in case of military or disaster scenarios. We also observe the need for greater automation, not to replace doctors, but to support them, freeing them from their repetitive tasks and allowing them to focus on decision making. And it wasn't long ago when we faced that huge pandemic I don't even want to mention. And it revealed the importance of minimizing human exposure and ensuring continuity of care through automated systems. And finally, in remote regions of crisis zones, accessible to access to real-time diagnostics is limited. So all of this motivates the development of a technology capable of fast autonomous medical assessment, available anywhere and anytime. Our research focuses on three primary objectives. The development of hybrid intelligence system that integrates in itself cognitive robotics with collaborative service robotic. Evaluation of robot mobility, sensor fusion technologies, and navigational algorithms, which refers to implementing them inside within that robot and medical environment. And finally, improving safety and patient comfort, which is essential when robots operate near vulnerable individuals. All these objectives support a unified concept, creating a reliable, autonomous medical station supported by intelligent robotic systems. Some background. Well, in robotics, we differentiate service robots, which perform tasks for users, from cognitive robots, which can resolve, learn, and make decisions based on environment and context. Well, in our system, these domains intersect, and service robots provide mobility, manipulation, and interaction with the physical environment, while cognitive robotics bring AI-based perception, user modeling, and decision support. The result is a collaborative mobile robot, or the so-called cobots, capable of functioning safely around humans and participating directly in healthcare workflow. So, before introducing our own system, it is important to position it within the broader landscape. As shown in that table, medicine today uses several categories of robots, from surgical platforms like the well-known Da Vinci, or rehab robots, logistic ones, telepresence systems, and disinfection robots. And each category responds to a specific medical need. Our automated medical station concept does not compete with these categories. It integrates some of their capabilities to create a more complete and autonomous healthcare unit, especially, suited for emergency or remote environments. Now, let me introduce the core concept of the work. The automated medical station functions as a self-contained diagnostic and assistance hub, and it includes sensors for vital signs measurement, automated diagnostic algorithms, dispensing modules for medication, telemedicine, connectivity for remote specialists, and built-in hygiene and disinfection systems. This allows the station to function independently or in support of overstretched staff, as I mentioned at the beginning. It is especially useful during disasters, pandemics, or military deployment. A few key elements that I can point out, that is the autonomous triage, which refers to collecting vital signs and assessing patient priority, trauma diagnostics, including imaging, data processing, data integration, that is combining sensor inputs for situational awareness, and of course decision support, which is the communication, which contains the communicating and recommendation to medical personnel. All these functions bring intelligence directly to the point of care to ensure rapid response without relying entirely on human availability. So let's move on to the system architecture. This diagram summarizes how the system components interact. On the left, we have our sensor suite. In that case, it contains IMU encoders and LiDAR sensor, all of them providing mobility feedback and environmental awareness. All sensor data flows then into the AI module, which performs sensor fusion, classification, anomaly detection, and planning. The AI module then interfaces with two domains. First of which is actuation, controlling the robot's mobility, and manipulation. And the second one is user-oriented system, which performs behavioral analysis, information storage, and decision support. Finally, through telemedicine integration, medical specialists can remotely supervise, intervene, or confirm diagnosis. One more time, we can see that the role of the medical staff, the doctor, has not been bypassed. This architecture ensures real-time autonomy while maintaining the human oversight. To validate the motion and sensing components, we performed experiments using a four-wheeled Mecanum wheel mobile platform equipped with IMU wheel encoders and LiDAR sensor. And these sensors feed into our fusion and navigation stack. There, in that stack, we evaluate different state estimations and control algorithms. This experimental setup allowed us to benchmark not only the hardware performance, but also the algorithmic reliability in dynamic conditions. So, now let's move on to the obtained results. This is the result comes from figure 3 of the publication. And it shows the robot velocity profiles. VX velocity demonstrates a realistic behavior, initial acceleration, steady movement, and smooth deceleration. The presence of noise reflects the real world working of that time sensor, and it is not an idealized simulation, so it is normal to have just a little bit of noise. The dynamic characterization confirms that the robot can move safely and predictably in a clinical environment, for example. We compared 4 fusion methods. You can see them on that chart. And our result shows that the EKF has the lowest latency but the highest estimation error. But the takeaway is clear. In EKF, it is optimal for real-time navigation, while the FGS is identical for offline trajectory refinement or post-analysis. As for the navigation performance, we then compared 3 navigational strategies, and the results are significant. The PID algorithms plus pure pursuit provides minimal safety margins and lower comfort. This is crucial for medical settings where robots frequently navigate around patients, doctors, and equipment. Key contributions that can be pointed out. We propose a new conceptual model for an automated medical station that integrates hybrid intelligent systems. A fusion of cognitive and service robotics has been presented, fusion into unified healthcare solution. We perform a complete benchmarking of sensor fusion and navigational algorithms. And together, these contributions move closer to reliable, autonomous medical assistance systems. In conclusion, our experiments show that advanced sensor fusion, particularly An EKF provides accurate and reliable state estimation needed for safe operation. And this technology does not aim to replace medical staff. It is designed to support, extend, and protect them while improving patient outcomes. Thank you, everyone, for your attention. If you have any questions, I would be happy to answer.
Any
Okay.
questions, sir?
Yes, yes. What about feasibility check of this system?
Excuse me, can you repeat?
What about feasibility of this system? Have you tested? Feasible. How
That other
feasible
part
this
is,
system it is?
I cannot seem to get the voice. It is very um, noisy. I cannot describe.
Okay. Are you getting my voice now?
Okay, it's fine now.
Hello.
Yeah.
Okay. How feasible this system is? Have you just checked the feasibility test has been done? Hello.
Yeah, give me a quick second.
Yes.
I need to translate something because my English is not first language. Sorry.
Okay. The question is
So,
regarding feasibility test.
yeah, feasible in terms of what do you mean exactly feasible? In terms of how experiments were carried out or something else in terms of maybe how what
Practical
were
applications. Practical applications.
well, practical applications for now, they were carried out in very controlled environment in our institutions. We because this is a recent work, we are in a process of negotiating with our how to say health system here in Bulgaria, and we are still waiting for paperwork and other bureaucratical issues that we have to deal with. So it is very recently that we will carry the tests in real hospital scenarios. But
Thank you.
for now, just in our lab.
Okay, okay, fine, fine. Thank you.
Thank you. Thank you, sir.
Juliet, ma'am, any questions for him?
Yeah. In addition to questions of Dr. Sabeno, so you mentioned, sir, that the system is already tested, right?
Yes, in lab
Oh,
conditions.
yeah.
Yes.
What problem in healthcare does the automated medical station aim to address this research?
What problem in? Can you repeat just the last part?
What problem in healthcare does the automated medical stations aim to address this research?
Aha, I get it. Well, you see, as I mentioned in the beginning, here in Bulgaria during the pandemic time, we faced tremendous issues finding staff. And our medical staff was basically to the edge of exhaustion, and that motivated us to find a solution to help them to replace their labor and to assist doctors, nurses, for instance, in providing measurement of various health data of the patient, in drug delivery, and so on. That was the key aspect that we wanted to address.
Okay, sir. How does the system contribute the sustainability of healthcare development?
I believe this question is to be answered when we hopefully begin implementing it, and the tests in real world scenarios are sufficient enough to do so. For now, I couldn't tell, honestly. I couldn't tell.
Okay, thank you very much, sir.
Yeah, thank you, ma'am.
Ma'am?
Yes, thank you. Now, next, I would like to call Janili M. Mandis to present her study on longitudinal analysis and important performance mapping of learner satisfaction, a basis for strategic intervention in the College of Computer Studies and Engineering.
Okay, so good morning, everyone. I hope my screen is visible.
Yes, ma'am.
Okay, so good morning, everybody. I am Dr. Janelle Mendez from Lorma College's San Fernando, La Union, and I'm going to present to you our study, Longitudinal Analysis and Importance Performance Mapping of Learner Satisfaction, and that's the basis of strategic intervention in the College of Computer Studies and Engineering. So, to begin with, our study. Okay, so our research provides now a detailed examination of learners' satisfaction would be a cornerstone of institutional excellence. Now, the findings are designed to inform now the accreditation processes, refined quality assurance protocol, and then the drive meaningful enhancement across our departments of operations. And also, it has now the longitudinal tracking from 2018 to 2025 and also includes now the importance performance mapping, and that would be the use of the multilinear regression. Now, the learner satisfaction would be the key indicator of institutional quality, accountability, and sustainability. In higher education, it directly influences student retention, the accreditation outcomes, and its institutional reputation. So this study positions now the satisfaction not as a one-time metric but a dynamic indicator that must be continuously monitored and strategically managed. So the methodology, our approach is quantitative approach, and the analysis, we have now the annual survey of the learner satisfaction conducted from 2018 to 2025. Now the total population, the inclusive sampling of our respondents are our whole department, ensuring now the comprehensive data coverage. And we have the standardized domain, which will be the data collected across the 5 key domains, which are the academic experience, administrative service, facilities and equipment, the student support, and overall satisfaction. And then we have now the data analysis that we utilize the descriptive statistics, the trend analysis, the multilinear regression, and then the IPMA for deep insights. So all of this, all the research adhered to a strictly ethical guidelines and data privacy standard. Okay, so now the descriptive analysis, we have the key performance areas wherein we have the highest rating based on the findings, the academic experience and student support consistently led in satisfaction scores, highlighting now the CCSE's core educational and pastoral care strength, wherein we have the lower rating, which we have the facilities and equipment and administrative services, receives relatively low scores, indicating now the opportunities for focus enhancement for the decision making of the administrators. So with this, we have compared now our predictor as the academic experience, the administrative services, facilities and equipment, and the support services, where in the interpretation for the academic experience, we have now the strong positive predictor, moderate positive predictor for administrative, significant but weaker predictor on the facilities and equipment, and then we have the strong positive predictor for student services. Now, the longitudinal trends, the stability and fluctuation, since we have now the pre-pandemic stability, the academic and support domain maintains strong, stable, and satisfaction level. Then 2020 to 2022, which is the pandemic impact, the facilities and administrative services experienced significant fluctuation and dips during the global health crisis. And 2023 onwards, the recovery and improvement. The post-pandemic data indicates now a clear recovery trajectory with notable improvement in all domains. So these trends underscores the resilience of our academic and support structure while highlighting the vulnerability in physical infrastructure and administrative process during the challenging times. So the predicting satisfaction, multilinear regression states that we have 0.45 for the academic experience, which means the strong predictor emphasizing now the impact of teaching quality and curriculum. And we have 0.31 for the student support services, a significant predictor in reflecting the importance and comprehensive student welfare. And also the variance explained for the root square. We have now the 79% for our model explains nearly 4/5 of the overall learner satisfaction variance. And these findings confirm that investigating an academic quality and robust student support yields the highest results in overall learner satisfaction. Now, having now im- the importance performance indicator. So we have the high performance, the academic and academic experience and support services consistently receive the highest satisfaction rating, wherein it highlights now the important of both highly important and high performing. Facilities and equipment fall under the high performance but low performance. Now, these quadrant signals urgently signify now strategic priority, indicating that improvement in infrastructure would yield significant gain in overall satisfaction. Now, for the text mining insights, the faculty and learning environment, the students highly value competent faculty, engaging learning environment, and positive peer relationship. For the infrastructure and technology, concerns now the frequent arose regarding facilities, the Wi-Fi connectivity, and modern equipment. And for the administrative efficiency, scheduling, flexibility, and clear in communication are common areas noted for improvement. So text mining provides now the qualitative depth, reinforcing quantitative findings and guiding targeted interventions. So the roadmap for our department is we have to maintain the high score, the sustained satisfaction score above 4.0, especially on the core academic areas. Invest on infrastructure, strengthen now the investment in facilities, laboratories, and technology upgrades. Enhance faculty development, so implement continuous professional development for faculty to ensure teaching excellence. Streamline administration, so improve administrative responsiveness and reduce turnaround times for student services. Also, the implementation of the CQI system or the continuous quality improvement system for ongoing assessments. And for the conclusion, this study decisively concludes that learner satisfaction at the College of Computer Studies and Engineering is fundamentally driven by academic quality and comprehensive student support. So our longitudinal and regression analysis illuminates now the clear institutional strength and persistent areas needing improvement particularly in facilities and administrative services. So the findings provide a robust foundation for strategic planning, ensures compliance with accreditation standards, and informing ongoing institutional development, all grounded in actionable student feedback and rigorous data analytics. So by addressing these insights, our department can foster now an even more enriching and supportive learning environment. So that would be the end of my presentation. Thank you so much. Any questions po?
Nilesh sir, any questions? Juliet ma'am, any questions for him? Her?
Yeah, ma'am.
Yes.
I go for it. Hello, ma'am. Dr. Mendez. Good morning po. So here are my questions, ma'am. So you mentioned in your presentations about the satisfactions, right? Okay, so which satisfaction indicators are perceived by the learners, and most important and less important?
Yes, ma'am. So thank you for that question, Ma'am Juliet. Actually, the highest performance on our satisfaction is the student support based on the mechanism, the student support and administrative support. So it got the highest high performing indicators, and the lowest performing is the facilities and equipment.
Thank you very much, ma'am. Second questions, ma'am. What area or what priority areas improvement can be identified based on the results on the performance important in mapping?
As I've said, ma'am, the low performance indicator is the facilities and equipment. So one of the intervention that the researchers can give now for the administrator would be to enhance, to upgrade, or to even give a better infrastructure, the facilities, the maybe the Wi-Fi and even the connectivity should be enhanced for the next school year, ma'am.
Thank you very much, Dr. Mendez.
Thank you, ma'am.
Ma'am?
Yes, thank you so much. Now next I would like to call Chung Nguyen Tran to present his study on metaformer-driven encoding network for robust medical semantic segmentation.
Hello.
Hello, sir.
Yeah, can you hear me well?
Yes, sir.
Yeah, thank you. I'm gonna share my slide. Yeah, can you see my screen now?
Yes, sir.
Okay, so now I'm gonna present our work, the paper Metaformer-driven encoding network for robust medical semantic segmentation. This is the outline of our work, and first I'm going to give the short introduction of the research. Secondly, I will review the related work, and next we are going to the most important part of the paper methodology. After that, I present the experiments which include the results and analysis, and finally we come to the conclusion for the paper. Medical image segmentation is the process of extracting meaningful regions, such as organs, tumors, or tissues, from medical images using computer vision to support diagnosis, treatment, planning, and research. So this is some examples of medical image segmentation, where we try to extract the region of interest for the purpose of analysis or research. So Usually when we developed a model, deep learning model, there is a trade-off between the accuracy and the complexity. Usually when we expect to develop a lightweight models, the accuracy seems to be lower. But if we try to make the model more accurate, we should have a complex models. So to develop better model, we should move to this point, and we can dive into it depends on the environment and the application. Our research target the clinical environment where we have the lack of computing resource and the need for real-time inference. So regarding the complexity, we should know that with the clinical environment, the complexity should be around here. So we try to make the accuracy of the model is the best around here. So the idea comes from this paper. Metaformer is actually what we need for vision, which is published in CVPR conference 3 years ago. So the author found that in the general architecture of uh, vision transformer is a very famous architecture in computer vision, and they found that the effectiveness of the vision transformer comes from its general architecture. But many researchers and many people found that the attention block is the most important. So they try with replacing the attention layer with pooling layer. And attention layer has heavy computational demand, whereas pooling layer has less computational demands. But they still produce competitive performance. So based on this idea, we adopt this block to build a medical segmentation model with less computational cost, but still produce competitive performance with traditional vision transformer. In short, the contribution of the paper include 3 points. Um, First is the network. We proposed MF and NETs, in which metaformer is adopted in the backbone, and the self-attention is replaced with pooling operation in the transformer block for efficient feature extraction. And last, we evaluate our model on multiple medical benchmarks, and it can achieve competitive performance with low complexity. Now let's review some related works. To develop our network, we use the baseline UNet. UNet is a very famous and fundamental network in computer vision. And based on UNet, many variants also developed, such as REST UNet, UNet plus plus, REST UNet plus plus. And also we also have review the concept of vision transformer. This is the general block of vision transformer. And based on vision transformer, there are many variants, including trans UNet, swing UNet, and transview. So we come to the most important part of the research, the method. As I mentioned earlier, we developed the model based on the metaformer paper, metaformer idea. So instead of using attention, the author tried to replace the token mixer. This block right here, they call token mixer, and we can replace with simpler operation like a pooling. So if we look at the chart here, we can see that the pool formula, which is the purple, this model can achieve a high accuracy with lower MAC. MAC is a kind of measurement for computation. So we also expect to develop our network within to produce the trade-off within this area. And this is the architecture of our proposed model. It has the U shape like the UNet. In the encoding network, we replace with the metaformer block. That's why we call our network metaformer-driven encoding network. Actually, we also replaced the metaformer block in the decoding part, but preliminary results show that it does not have a good result. So we just keep developing the network with the encoding with metaformer. So after four times of downscaling with metaformer encoding block, we have an SPP block. SPP block is to gather the information with different scales using pooling also. And after that, we have a refined feature map here, and then the mission of the decoder is to reconstruct the feature map to get back to the original resolution. And finally, we have the segmentation output. And that's the overview of our proposed network. So we come to the experimental result and the analysis. To conduct the experiments, we use two datasets. The first one is iris segmentation. The name is Cassia. And the second task is skin lesion segmentation with ISBI 2016 dataset. This is the information of the number of images in each dataset. Generally, we use 80% for training and 20% for validation. And this is our experimental settings. We trained the network on a Linux system with T4 GPUs. The network is developed based on PyTorch framework. During training, we use the ADAM optimizer and trained the network with 50 epochs. The loss function that used is the binary class entropy loss, which is a very common loss function in many segmentation tasks. And the learning rate is set to 10 to -4, and it is gradually decreased to 0 at the end of the training. The network input size is 260 by 256 by 256. And we evaluate our quantitative performance using the IOU, which is the intersection over unions, and the dice coefficient. And also we assess the model complexity using parameters, number of parameters, and the flops, which is a measurement for the computational demand. This is the table for the comparisons of various methods in terms of accuracy and complexity. So based on this, we can notice that our network can achieve the competitive performance with the baseline. And also we have like a good balance between the parameters and the flops. The params here denotes the model size, while the flop denotes the inference time. So to better visualize the results, we can have this chart. So as presented earlier, within the trade-off, we expect to develop our network to produce the trade-off in this area. So in our experiments, I can say that we are successful doing that, and our network MF and net can achieve a competitive performance in terms of accuracy with less model complexity. Here, this point is our model on the two data sets. And also we have several examples with the quantitative results. This is the result on KCR data sets. So FNENet can produce the quite good results, and the maps are visually closest to the ground truth with clean and continuous contours around both iris and the pupil regions. Regarding the skin lesion segmentation on ISBI datasets,
Excuse me,
the
sir.
network. Yeah.
Sorry for interruption, but you've crossed your 10 minutes.
Oh, okay. Sorry. Okay. So can I go ahead to the conclusion part?
Yes, sir.
Okay. Yeah, in this paper, we introduced the MF and NET, and this is an efficient network for medical image segmentation based on metaformer. So we replaced the self-attention with a pooling layer in transformer and it delivers an effective global contact aggregation at low complexity. In the bottleneck, we use the SPP block and we replace the ReLU activation with the switch activation. And with our experiments on KCI and ISPI datasets, the proposed model can achieve competitive accuracy with reduced computational costs against state-of-the-art approaches. Yeah, and that's all of our work. Thank you for listening, and I welcome any question. Yeah.
Nilesh sir, any questions?
Question from my side. Well presented.
Okay, Juliet ma'am, any questions for him?
Yeah, I just want to clarify now for the presentations. No, hello, sir. Good morning. Good afternoon. So my questions is, what problem in existing segmentations methods that this study aim to solve?
You mean the existing challenges in the clinical environment?
Yeah, the existing segmentation methods.
Yes. So let me go back to the trade-off here. So usually when we develop a segmentation model, we always have this trade-off for reference. So usually the model this assisting model try to get the very good accuracy. So with that purpose, they produce the very complex model and with advanced architecture and a big model size. So they cannot be deployed in clinical environment because in clinical environment, as I presented, there's a lack of computing resource and the need for real-time inference. So we try to reduce the model size, but keep the accuracy. So that's the main purpose of the work, and we can solve the challenge, solve the problem of the existing methods, which is their model size. Model size. So the short question is their model size. So.
Okay, another one question, sir. How can this model be applied in the real world clinical setting?
Oh yeah, actually that is our next step because this is actually an ongoing project, and right now we just tested our model on PC, and in near future we are going to bring it to main board, such as the embedded computer, and we can deploy to a uh, uh, mobile environment or clinical environment. And actually, that is our next step. We try to compress the model more and put it to embedded board. Yeah, and that's how we plan to make this practical in real world applications.
Okay, so thank you very much, Mr. Trent.
Yeah, thank you.
Ma'am.
Yes, thank you, sir. So next, I would like to call Swati Rastogi. Swati ma'am, if you're present, please start with your paper. Bakar Akil Zuen. Bakar sir?
Yes.
Yes, sir. Please present your paper on the effect of accounting information comparability on credit risk, the moderating role of accounting information asymmetry.
Okay.
Yes, sir. We can see your PPT.
Good morning, ladies and gentlemen. I'd like to begin by expressing my sincere gratitude and appreciation to the organizers of a conference for their valuable efforts in making this event a success. I also extend a warm welcome to all distinguished guests and participants. My name is Bakar Aqil Zwan from the University of Kufa, Iraq. It's a great honor to present my research entitled The Effect of Accounting Information Comparability on Credit Risk, the Moderating Role of Accounting Information Asymmetry. The research model and cloud three variables, the independent variable comparability. The dependent variable is a credit risk, and the moderating variable information asymmetry. In today's global financial environment, credit risk represents one of the most serious challenges faced by banks and financial institutions. Credit risk arises when borrowers fail to meet their financial obligations, such as the payment or defaults. which can lead to major losses for lenders and in severe cases financial instability. Moreover, the global economic environment can amplify these risks, especially during periods of uncertainty or market volatility. The risk became even more pronounced during the financial crisis. Past experiences such as the 2008 global financial crisis demonstrated how widespread borrower defaults can escalate into severe liquidity crises within the banking system. During a crisis, the ability to repay loans decline, defaults increases, and the credit loss amount. The value correlate decreases and market volatility rises, placing financial institutions under significant pressure and limited their capacity of financial economic activity. Therefore, understanding and effectively managing credit risk is critical, preventing crises from worsening and for safeguarding financial stability. Accounting information plays a crucial role in the decision-making process in investor credit and regulators. The usefulness of the information depends on its qualitative characteristics, the most important of which is comparability. Comparability allows users to analyze and contrast financial statements across time and between firms, enabling them to make a sound financial judgment. The importance of comparability becomes even more apparent during periods of high market volatility or financial turmoil, as investor and creditor rely on consistent accounting information to assess companies' resilience to shocks. In time or crisis, financial decisions became more information sensitive, and the lack accurate comparability between companies can lead understanding or overestimation of risk, impact the cost of financial and investor confidence. Information asymmetry sorry. Unfortunately, in many emerging market, financial reporting still suffer from information asymmetry, where some market participants, often insider, possess more information than others. The imbalance can distort credit assessment, and increase uncertainty, and contribute to poor lending and investment decisions. A lack transparency creates knowledge gaps between ordinary investor and this with influence with the companies. This information asymmetry makes valuation process more complex and increase the likelihood of decision based on incomplete or misleading data. In the context, my study explored whether improving the comparability of accounting information can reduce credit risk, and other information asymmetry weakness this relationship. The main problem addressed is this study in the third posted by credit risk to financial institution and the market stability, especially in the presence of asymmetric accounting information. When firm had negative information or disclose incomplete data, it has become difficult for lender to accurately evaluate financial health and increasing the likelihood of wrong credit decisions. This research aims to achieve three main objectives. One, to examine the impact of accounting information comparability on credit risk. Two, to test the moderating role of information asymmetry in this relationship. Three, the profit policy recommendation for improving financial reporting, transparency, and credit risk management. The study used data from 9 Iraq banks listed on the Iraq Stock Exchange for the period 2016 to 2023, generating the 72 firm year observation. The banking sector was specifically chosen for two reasons. First, it is the most complex and opaque sector in terms of information disclosure. And second, it represents the economic backbone of any nation responsible for financing, investment, and liquidity creation. Understanding how accounting information affect credit risk in bank can therefore provide valuable insights for the stability of the entire economy. The study relies on a quantitative measure to assess the research variable, taking into account their typology for the Iraq environment. A credit risk is measured using Altman's model for emerging market, which estimated the probability of financial default. This model is well suited for emerging economies like Iraq, where financial data may be limited or least standardized. And accounting information comparability is measured using the DeFranco models, which use financial statement similarity indices to reflect how consistently accounting methods are applied across firms. Higher company allows users to more easily compare financial results and make fair assessment. Finally, information asymmetry is measured using the stock price volatility indicator because based on the standardized deviation of stock price within 15 days before and after publication of financial statements. The result of regression analysis revealed several important findings. One, accounting information comparability significantly reduces credit risk. When accounting data are consistent and comparable across firm, lenders can better assess a company's ability to meet financial obligation. This leads to more accurate credit evaluation and a lower risk exposure. And two, information asymmetry weakness this beneficial relationship. In firm or market where insider information is not evenly distributed, even highly comparable data lose part of their effectiveness. Information gaps prevent fair comparison and reduce the confidence of investors and creditors. These results reflect the policy implication that improving the transparency of financial reporting can enhance credit risk assessment, particularly in emerging markets where regulation and governance are still under development. The findings confirm the high-quality, comparable financial information contributes directly to financial stability by reducing uncertainty and promoting informed decision-making. To calculate the study highlighted three main messages. First, accounting information comparability is a vital tool for reducing credit risk and improving the efficiency of financial markets. And second, information asymmetry remains a sector obstacle that can limit the usefulness of accounting information. Third, the regulator and the policymakers should focus on enhancing disclosure standards, corporate governance, and credit information systems. I strongly recommend that future research extend this study to a larger sample and multiple sectors. Apply the same model to personal economic sector will provide a more comprehensive understanding of how accounting comparability contributes to financial stability in different contexts. Additionally, combining qualitative data analysis with qualitative interviews of financial expert and bank manager could offer deeper insight into the practical challenges to application transparency reporting and risk assessment mechanisms. In summary, in study appropriate advance that improving the comparability of accounting information helps to reduce credit risk, enhancing investor confidence, and strengthen financial stability in emerging market like Iraq. Thank you very much for your kind station. Since I speak Arabic and there is not translator is available, and this is not because I am advanced answer question, but because my English vocabulary is limited. I would appreciate if any question could be sent via email. Thank you again.
Thank you, sir. Any questions? Nilesh, sir, Juliet, ma'am, any questions for him?
Yeah, ma'am. Good afternoon. Good afternoon, sir.
Ma'am, you got mute.
Oh, okay. Sorry, ma'am. Okay. Sir, my questions is, what is the effect of accounting information comparability on credit risk?
I'm sorry, my English vocabulary is limited. I would appreciate it if any question could be sent email.
Oh, okay. So, I send na lang po. I send na lang, ma'am. Sir. Ma'am,
Yes, ma'am.
I will send my questions through the chat book na.
Okay,
Chat
okay.
book.
Yes, ma'am.
Thank you.
Thank you.
Thank you so
Thank
much.
you, sir.
Thank you so much.
Now, next, I would like to call Sajidur Rahman, sir. Sajidur, sir,
Yes,
or
yes.
any of the co-authors? Yes, sir. Please present your study on WebSecure, a post-quantum P2P end-to-end encrypted chat framework with Kyber key exchange and adaptive noise injection.
Yes. Am I audible?
Yes, sir.
Okay. Good morning, everyone. In my country, this is good morning. I don't know if it's evening in you, Thailand. So, the saying, good morning, everyone. My name is Sardur Rahman. Today, I am presenting our paper titled Web Secure, a post-quantum P2P end-to-end encrypted chat framework with Kyber key exchange and adaptive noise injection. To guide you through our presentation, here is our agenda. We will start with the introduction to the problem space, review the existing literature, detail our methodology and the mechanics of Kyber, walk through our security framework and implementation, showcase the user interface, verification, and benchmarks. Finally, we will analyze our network performance and conclude with our future work. So the emergence of quantum computing presents an existential threat to modern secure communication. The traditional algorithms like RSA and ECC are vulnerable to source algorithm. WebSecure addresses this by introducing a framework that leverages MLKEM 1024, which is in short named Kyber, for quantum safe key exchange and adaptive noise injection to mitigate traffic analysis, ensuring both content and metadata security. So, in our review of different papers of current literature, we observed that while lightweight cryptography exists for IoT, its quantum resistance is unproven. Conversely, lattice-based cryptography, specifically crystals, Kyber has been validated as a robust candidate for NIST standardization. However, a critical gap remains. There is a lack of practical and unified architectures that integrate these theoretical post-quantum primitives into usable web applications without compromising performance. WebSecure is designed specifically to bridge this gap between theory and engineering. So, in methodology, our methodology is built on a defense in depth approach. Beyond encryption, integrity is paramount. We utilize a hybrid model combining post quantum asymmetric cryptography for the handshake and symmetric cryptography for the session. We also employ HMAC SHA 256 verification. Every message includes a time-stamped HMAC. The receiver cryptographically verifies this tag before attempting decryption. If the verification fails, the message is immediately rejected. This effectively prevents replay and tampering attacks. So, how Kyber works? At the core of our security is Kyber key exchange mechanism. The details here. So like a key generation pair, a key pair is generated with a public and private key pair encapsulation. Pair B uses pair A's public key to encapsulate a shared secret into ciphertext. Decapsulation. Pair A uses their private key to decapsulate the ciphertext, retrieving the same shared secret. This results in both parties possessing an identical symmetric key for this session, ensuring forward secrecy without ever transmitting the key itself. This slide illustrates the comprehensive architecture of WebSecure. We utilize WebRTC for direct peer-to-peer data channels, eliminating the need for a central server to store messages. The signaling server is minimalist, handling only peer discovery and authentication using Argon2 hash. Only on the client side, the Kyber mechanism secures the channel, while adaptive noise injection actively obfuscates traffic patterns to protect metadata privacy. So implementation, for our implementation, we utilized a modern standard compliant tech stack aimed at a broad compatibility. For frontend, we used HTML5, CSS3, and JavaScript with PRJS for networking. For cryptography, we used Kyber, or let's say MLKM 1024 package for post-quantum operations, and CryptoJS for AES 256. For backend, we used Node.js Express with MongoDB for ephemeral user data. This stacks ensures that WebSecure is not just a theoretical model, but a deployable web application. Here we visualize the full end-to-end encryption flow. It begins with asymmetric phase, where Alice and Bob use Kyber to securely derive shared secret. Once established, we transition to the symmetric phase. Messages are encrypted using AES 256 and signed with HMAC. This hybrid approach gives us the quantum resistance of lattice with speed of symmetric encryption, ensuring high performance in real-time chat. So this is our chat UI, and with verification, usability is a key component of security. Figure 5 shows the chat interface, which includes controls for our adaptive noise injection. Here, injection allowing users to toggle traffic obfuscation, which is a choice if they want. In Figure 6, it demonstrates our MITM defense, man-in-the-middle attack. The system generates 64 character shared secret fingerprint. Users can verify this security code out of the band, for example, by scanning the QR code to cryptographically confirm they are speaking to the intended pair. So for comparison, this table compares WebSecure against traditional systems, unlike RSA or ECC, which are vulnerable to quantum attacks by Shor's algorithm. Our implementation, MLKEM, provides post-quantum security safety. Furthermore, while standard apps rarely address traffic and analysis, our noise injection feature actively mitigates metadata leakage. We also utilized Argon2, not bcrypt, for hashing, offering superior resistance to GPU brute force attacks compared to legacy bcrypt methods. So in here, we conducted rigorous benchmarking to validate performance. Figure 7 shows the Kyber key performance. Even on standard hardware, the exchange completes in milliseconds, making it negligible to user experience. On figure 8, it analyzes the noise injection matrix. It demonstrates that the overhead introduced by random dummy packets is minimal, maintaining a high throughput while successfully masking traffic patterns. So here we can see the difference between RSA and Kyber. So even though like most of the company are using RSA even now, even though we are gaining on the quantum threat, but very few companies are trying to get secured on the post quantum security. So it's very lightweight and also secure. It has port security is natively supported, but on RSA it's not natively supported. Just requires TH combination. As expected, it's resistant to any known quantum attacks. But RSA is broken by Shor's algorithm. Fast key generation, which is possible in Kyber, slower on RSA, comparatively slower. But as expected, Kyber has a bigger size of key size, but RSA is smaller. Security basis on lattice, its Kyber is lattice based. On the other side, it's an RSA is an integer factorization problem. Comparative analysis. So expanding on our performance, table 3 details Kyber operations across devices. We observed that on low-end devices, total key exchange time remains under 10 milliseconds. Table 4 evaluates the network resilience. WebSecure maintains a 100% success rate across various scenarios, from high-speed Ethernet to high-latency satellite connections. Note that key exchange time naturally increases with latency, such as 1247 milliseconds for satellite, but protocol remains same. All this benchmark was done by automation testing using JMeter and other testing materials. Net traversal performance. So crucial for any PTP application is ability to navigate network barriers. Table 5 presents our net traversal performance by utilizing STARN and TARN servers. WebSecure achieves a 100% success rate across all net type, including symmetric nets. The connection establishment time remains consistently low, averaging around 8.6 milliseconds, regardless of the net type. This confirms that our P2P architecture is robust enough for real-world deployment across diverse network environments. So, in conclusion, WebSecure successfully bridges the gap between a theoretical post-quantum cryptography and practical engineering. We have demonstrated a framework that balances quantum resistance and metadata privacy and with user experience. For future work, we will move forward with our research. We'll focus on WebAssembly acceleration to further optimize the cryptographic operations, mobile adoption, extending the framework to native mobile platform, group messaging. Currently, this just works as a peer-to-peer, one person to one person. Researching, so in the future, we will add group messaging. Researching this post-quantum algorithms for multi-party chat. So here are my references. Thank you so much for your time and attention. I am now happy to answer any questions you may have regarding the WebSecure framework.
Nilesh sir, any questions for him? Juliet ma'am?
Oh, yeah, ma'am. My questions, sir, how this methodology protect against pampering and replay attack?
Oh, sorry, ma'am. Can you repeat the question?
So based on your presentation, And the methodology, how does this methodology protect against pampering and replay attack?
Uh, to show you visually. It generates an HMAC. This is the step here. As expected in cybersecurity world, tampering is expected, right? So before the encryption, let's say encrypted, a message is encrypted here, right? Then it generates an HMAC. And this is the second step. Then sends the message. Then an user receives the message. Then it recomputes the HMAC. Then compares the HMAC. Then only after comparison, if it's actually from him, then it's decrypts the message. Or if the HMAC does not match, the receiver rejects the message. And also it's alerted in the user UI in the chat framework.
Okay. So, another question, sir, based on my first questions. Can this method guarantee the confidentiality?
Yes.
Okay.
It accounts for all confidentiality and integrity and accountability.
Yeah. Thank you very much, sir. That's all, ma'am.
Yes, thank you very much, sir. Now, this is a last call for Sagar Mekala and Swati Rastogi. I repeat, Sagar Mekala or Swati Rastogi or any of the co-authors present. All right, we'll move on to the closing remarks. I sincerely thank our authors for their excellent presentations and contribution in the session, and all our participants for being a part of this international conference. We, on behalf of the whole team, thank you for the support during this version of the conference, and we will be happy to have you in the next version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of MCT4SD 2025. I would also like to thank our session chair, Dr. Juliet Menor, for chairing this session. I'm sharing a token of appreciation on behalf of the team and would request you to share any concluding remark for everyone here.
Okay, thank you very much, ma'am. As being the research, to close this session, so I will extend sincerely appreciation to all you have contributed, our presenters, and demonstrated exemplary scholarship and the insights shared today and added meaningful value of our collective understanding. I also acknowledge the active engagement of all participants, panel who questions and reflect, enrich this disclosure. May I acknowledge, exchange these sessions, continue inspire further inquiry and academic excellence. Thank you very much for your presence and participations. This session is now formally adjourned. Thank you, ma'am.
Thank you so much, ma'am. I would also thank Nilesh Sable for chairing our session. Thank you, sir, and I'm sharing a token of gratitude on behalf of the team.
Thank you. Thank you so much, ma'am.
Yes, sir. If you have any few words for us, you may.
No, ma'am. Thank you. Thank you.
Yes, thank you so much. And with this, we conclude. Yes, ma'am?
Yeah, ma'am, could we have a photo off before we adjourn?
Yes, yes, ma'am. I was about to say that. I request everyone to please turn on your cameras for a quick snapshot of this conference.
एक मिनट अभी ट्रेन चालू करायची. Thank you so much.
Yes, thank you,
Okay,
everyone.
thank you very much.
Have a great day. Thank you.
Thank you.